Okay, hello physical science class, this is Mr. B, and we're going to go ahead and get started right away with our first video, and we're going to take a look at Chapter 1 to start off, which makes sense, and the title of this chapter is Science Skills. So within this chapter we're going to learn various things that kind of help us out to be successful in a science classroom and kind of give us a basic understanding of what to expect in this class. And so once we break it down even further, before we really even get to these skills, we first have to figure out what science actually is, and that is actually the first section here. So we're going to section 1, what is science? And to start, they tell us that science is just a way that involves asking questions about nature and then finding ways to answer them. So usually that can be anything that we think of on Earth. Again, in nature and the natural world are big things for science, so when you think of science you have to think of nature, and we'll maybe explain a little bit more of that later on in class. But if you look to the picture of the right, this is actually a picture of Mars and then a rover in 1997 that was sent up there to take a look at Mars. So our science has actually advanced so far that now we're not just looking at nature on Earth, we're trying to explore the nature of other planets near us as well. So again, science involves asking questions about nature. Again, nature, the big thing you would need to know there, and finding ways to answer them. And one way we can get science is from curiosity. So if you look here, we have some examples of things that you might not think of as being science, but they are technically classified as science. They ask, have you ever checked what was living at the bottom of a pond? Taken off the cover of a baseball to see what was inside? Tried putting more chocolate or less in your milk to find out how much would give you the best flavor? And these are all examples of curiosity, and that is in fact the basis of science. So I'm sure you guys have all asked questions like this in your lifetime, and you might not have even really thought what you were doing, but there is definite science involved. There's different branches of science involved in each one of these, and again, it all just starts with curiosity. If we didn't really care to ask questions, science really wouldn't have advanced to the point that it's at to today, so it is a big thing. So curiosity is kind of the foundation of it. So if you're a curious person, then you're already on a good path here to be successful in the science world. However, curiosity is limited because it only provides us with questions, but results rely on finding answers. So you can't just be a curious person and ask a lot of questions and be satisfied with it. You actually have to go out and you have to kind of carry out what we call an experiment. Again, hopefully you've heard of that term before, but we'll get into that more later. But you actually have to carry out one of those if you actually want to find some answers. And when you are carrying out experiments, you're going to make some observations that are qualitative or more descriptive observations. So this is a big word right here, qualitative, which is descriptive. And then kind of on the opposite end of that, we have observations that are quantitative, that are numerical. So what this means is that maybe if I give a good example of a qualitative piece of information would be like if you're doing an experiment outside and you see and you're studying flowers, and let's say you look at the flower and you make the description that the flower is very beautiful. Now there's no real concrete way for someone to measure how beautiful something is. It's kind of your opinion, so it's a descriptive type word. So that's what we think of when we think of qualitative. Now when we go down here to the opposite, the quantitative, which is the numerical, that would be, again, if we're doing the same experiment and you decide to pull out your ruler and you measure the stem length of that flower, and that stem length just happens to be, I don't know, 32 centimeters. So that would be a quantitative piece of data, something that is physical, that you can actually measure, that you can use a tool to measure. So that is our difference between qualitative and quantitative data here. And then if we keep going here with our curiosity and finding answers, some questions, and then they give the example of how the universe began, cannot be answered by direct observations and measurements, but only by other kinds of evidence. So there's no real data that we're going to go out and gather, again, us personally, that are actually physical, direct things, because obviously none of us were around when the universe began. So we're going to have to use other types of experiments, other types of information that are a little bit more far beyond, again, these qualitative and quantitative data. But for the most part, when you're carrying out an experiment, the things you observe can be classified as one of those two things. So moving on to our next one is science and technology. So we kind of gave a basis of what science is, and now we're going to talk about technology, because that, if you've actually haven't been awake for these last 10 years, you might not know that technology has a big role in science, but it does. science and technology are interdependent, and advances in one lead to advances in the other. And again, they're giving us another little definition of science here, so you might want to jot this one down, that science is a system of knowledge and methods you see to find that knowledge. So the goal of science is to expand our knowledge. So basically, again, it involves asking questions. It's this very, again, it says a system of knowledge and the methods you see to find the knowledge. So it's basically just some certain practices to have the goal of expanding our knowledge. That's what science is. And then technology is once we obtain that knowledge, we use it to solve practical problems. And then the goal of technology is to apply the knowledge that we learned. So that's probably the big difference between the two. Science is actually used to expand knowledge, and then we use technology to apply that knowledge that we have learned. And the example that they give is the telephone. So it was invented in 1876, and again you can see over there on the far left down here what that telephone might have looked like. And then in 1927 it was possible to make a phone call from New York to London. First mobile telephones were invented during World War II, and those paved the way for our modern cell phones that we have today. And in each step, new science, again, just little advances on how little circuitry and the communication world works, was made to improve the technology of the telephone. And again, now we can do things with our telephone that, again, more powerful computers, or the computers that were used to get to the moon, don't even have really some of those capabilities. And then now we're going to talk about really quickly the different branches of science. And actually, you know what, we're going to hit that one in our next video. So if you have any questions, go ahead and write them down and let me know if you have any questions.